Hello everyone, welcome to our new stream. I'm Jed. Our company, Shandong Boyoun Heavy Industries Company, was focused on the R&D, fabrication, marketing, on-site technical spaces of steel formwork, footbridge, viaduct, tunnel engineering. Today, our new stream content is mainly about key technologies and applications for new schedule for long-span composite bridges. As long-span bridge engineering continues to develop more complex and greater spanning compatibility, still considered composite bridges are becoming the mainstream direction of modern bridge design due to their excellent economy. In the process of turning these large bridges from drawings into reality, steel formwork system, especially center-level form travelers and segmental accessibility formworks, directly affect structural forming quality and construction efficiency. In this live stream, we will first discuss new structural system of long-span composite bridges from three aspects: structural form inversion, material selection and composite design, and structural detailing characters. At the same time, we will analyze what technical requirements their new structures place on steel formwork equipment and how to support them. Then we will go further into key technologies, including material performance and structural optimization. 2.3 Structural form inversion. Structural form inversion of long-span composite bridges is very critical to meet the needs of modern bridge engineering. Traditional single structural forms, such as poor steel arches, have difficulty coping with longer spans and more complex loads. Originally, combining steel and considerate can fully exploit the advantages of both materials, improving the overall load carrying capability and stability of the bridge. In terms of structural form, combining multiple systems such as bridges, beams, and cables together achieves multiple direction. One thing wrong, nothing here, is that the realization of these structural forms places here demands on the block accuracy, accessibility, safetiness, and reusability of steel formwork. For example, in segmental accessibility construction, precast segmental moves and hierarchical formwork systems must work together to complete precise control over complex alignment at each two-beam connection. The design and processing quality of special-shaped formwork directly affects the effectiveness of joint stress. Through reasonable structural shape examination, material contamination can be reduced, achieving a combination of economy and durability, while also providing good conditions for standardized and serialized manufacture of steel formwork. 2.2 Material selection and composite design. Scientific material selection is very important for improving the structural performance of long-span composite bridges. steel is widely used in mean load bearing columns due to its high strength and good plasticity. Consider it provides excellent cohesion performance and durability, and is often used as secondary columns or protective lasers. Reasonably combined steel and considerate allows their respective advantages to be fully utilized and complement each other. The application of modern high-performance steel and considerate further improves bridge load capacity and durability while reducing structural self-weight and subsequent maintenance costs. From the perspective of us as a steel formwork manufacturer, material combination design also affects the material selection and matching of formwork system. For example, at steel considerate connection stations, the stiffness, surface flatness, and bending performance of steel formwork directly affect considerate forming quality and interface cooperation ability. In composite beam bridges constructed using center-level cast-in-place construction with formwork travelers, the traveler must bear the weight of considerate and also adapt to deformations caused by pre-testing. Its materials and schedule must be highly coordinated with the main schedule design by automating material matching and connection methods. Evident and correlated stress transfer can be achieved while also considering construction convenience and later maintenance convenience, laying a solid foundation for some stable development of overall structural performance. 20.3 Structural detailing. Now, long-span composite bridges show two characters in structural detailing: diversity and coordination. The structural detailing includes not only the design of main load bearing columns, but also the system integration of connection nodes, supports, and feasibilities. The high-strength node technology used when connecting steel arches and considerate mean beams can effectively control local stress connection and definition, ensuring the continuum of the overall schedules. The detailing design fully considered temperature changes, load effects, and construction definition requirements by setting expansions joints and pre-testing adjustments. The schedule is given self-adaptive adjustment capability. From the perspective of steel formwork supporting construction, these detailing characters put forward clear requirements for the block support system and adjustment of this formwork. For example, in beam segments with pre-testing, the reserved hole position accuracy on steel formwork is to reach millimeter level to avoid stress consideration caused by misalignment. The overall detailing impedance and standardization, which frames, manufacture, and installation. This is exactly the core advantages of us as a steel formwork manufacturer. Through standard system or adjustable connects and common access, construction efficiency can be significantly improved and engineering risks reduced. 3. Above, we discussed the design of new structural systems for long-span composite bridges from 3 concepts: structural form inversion, material selection, and composite design, and structural detail. We also analyzed the supporting solutions of steel formwork system with them. The innovative design of structures lays a good foundation for the spanning ability and overall performance of bridges. However, to transform these design concepts into safe and reliable engineering, we need to thoroughly address a series of key technologies. Now, the following content as a continuation of our news stream today, I will introduce key technology research of new schedules for long and smart and health. (3.1) The fundamental criteria for the safety and stability of long-span composite bridge schedules is measured performance only by comprehensively and understanding the stress conditions of the bridge and various working conditions can we provide scientific basis for reasonable design and auto-examination by building high precision finite models and combining dynamic and states. Under multiple complex working conditions, we can carefully review the stress distribution, definition partners, and possible stress consideration areas of the overall bridge schedules and key composite under different loads. There be occurrently weak points. Structural auto-examinations is based on the results of stress analysis using multiple automations. Through autopilot design, reasonably arranging the rotation of steel and considerate materials can reduce the structural self-weight while increasing load compensating, achieving the evident auto-examination. The deeper analysis of numerical performance combined with structural auto-examination not only greatly extends the stress life of bridges and raise the safety protection level, but also reduce daily maintenance and repair costs. 3.2 During long-term optimization, long-span composite bridges bear a very large number of ulterior loads. In the design process, finite life and non-destructive testing technologies are integrated to achieve dynamic assessment of fatigue risk. For the detailed design of the schedule, the focus is on eliminating stress consideration, improving writing process and connection methods to enhance through significant figure design and material early warning methods. The bridge schedule maintains a significant safety throughout its sales life, greatly improving bridge reliability and operational safety. 3.3 For steel schedules, because of their consideration characters, we use multiple layer coating methods together with the consideration reset loads and protection technology, thus forming a reliability system protection system. For considerate parts, we use high-performance considerate max designs together with surface sliding treatment to improve permeability and cooperation. In schedule detailing, the focus is on avoiding water and corrosive material retention, thereby maintaining consistency of protection as schedule details. 3.4 With the continuous development of information technology, smart system has been widely applied in long-span composite bridges and have become a very important means of bridge health management. By arranging various settings such as strain, temperature, and fiber, we can collect real-time data on schedule stress conditions, definition conditions, and environmental patterns, thereby achieving comprehensive dynamic, combining big data and critical to analyze and evaluate the collected data can promptly that schedule and potential risks, preventing safety assistance. Smart systems not only improve the scientific base and timelines of bridge maintenance, but also provide data support for evaluation and related work in the future. Smart technology will promote the continuous development of the bridge management toward stagnation and further raising the level of schedule safety protection. Thank you all for watching the research on key technologies of new schedules for long-span composite bridges cover multiple levels, including basic performance optimization, durability design, protection systems, and smart assessment. The coordination and advanced of these technologies is the core of ensuring safe, durable, and economic bridge operation. As a professional bridge steel formwork manufacturer, our company, Shandong Boyoun Heavy Industries Company, will continuously pay attention to the development of cutting technologies and is committed to providing high formwork systems and construction support for various bridge projects. If you have any needs regarding related technologies or products, please feel free to contact us at any time. We look forward to working with you on your next bridge project.